Hello and welcome to this class. The topic for today is scatter plot. My name is Eunice Frimpong and I will take you through this topic. What is a scatter plot? In data science or computer science, cybersecurity, it is often important to understand whether and how two variables are related. A common tool for this is the scatter plot, which visually shows how one variable changes with respect to another. So for example, does increasing system load affect server response time, or does increasing study time improve exam grades? We collect two related quantitative variables and plot each observation as a point on a graph. Here are some examples of variable relationships. Now, scatter plots can help you explore questions like, does increasing the number of users on a website slow down page load time? 2, does the number of login attempts increase during certain hours of the day? 3, does the number of hours of sleep affect productivity? Or does exercise duration influence calories burned? And then also, does the number of lectures attended affect exam performance? Or does time spent on social media affect GPA? So you see, these are examples that you can relate to, and these are questions that we sometimes ask ourselves. And the scatter plot can help us check if there exists a relationship at all between these variables and how the relationship looks like. So a scatter plot or a scatter diagram is a graph that displays two numerical variables as coordinate points on a 2D plane. So each point represents an observation with one variable on the x-axis and the other on the y-axis. It is used to visually assess whether a relationship exists between the variables and what kind of relationship it could be. So for example, you could plot hours studied on the x-axis and exam score on the y-axis. Each point will show you how one student's study time relates to their end of year results or end of semester results. So why should we use a scatter plot? Use a scatter plot to check if a relationship exists between any two variables. Determine if the relationship is positive, negative, or none. And then also assess the strength of the relationship, if there is, whether it is strong or weak, and detect any outliers or unusual data points. So in real life applications, we can have the case of input size versus execution time, or RAM size versus performance speed. We can also have login attempts versus time of the day, file size versus encryption time. You could also be checking website traffic against the response time or number of users against the database query time. Other examples could be hour study versus your exam score, or your age versus your blood pressure. So does your age, could it be that the older you are? No, is there a relationship between your age and your blood pressure at all? And if there is, how is the relationship like? You can also compare advertising expenditure and product sales. So when we talk about scatter plot, we talk about two important variables. We study the relationship between these two variables. And the first one is the independent variable, which we will plot on the x-axis, and the dependent variable, which we will plot on the y-axis. So the independent variable is the input or the cost. It is the variable you can control or you can choose. So for example, the number of hours you study, or the number of time or the amount of time you use to do exercise. Now, the dependent variable is the output or the effect. It changes in response to the independent variable. So it responds to what you do in the independent variable case, okay? So for example, your test score. So your test score will respond to the number of hours you studied, or the calories burned. Your calories burned depends on amount of time you spent in exercising. Right. So how do you decide? First of all, you need to ask yourself which one depends on the other. And that is the dependent variable. Let's look at a scenario. A developer wants to find out whether the number of items passed to a sorting algorithm affects how long the algorithm takes to run. So could it be that if we put in few items, it will take a shorter time? And then if we put in many items, it took a longer time. We don't know, but we want to assess it. So in this case, what depends on the other? I see that then how long the algorithm takes to run depends on the number of items passed to the sorting algorithm. So the dependent variable will be the execution time. And then the independent variable, the one you can control, is the input size, which is the number of elements you are going to pass to the sorting algorithm. Now, why should you use a scatter plot? It helps to check if, first of all, there is a relationship, and secondly, if there is a pattern and how strong the relationship is. This is a typical use case when analyzing algorithm performance. So let's look at an example here. We have a question. A researcher recorded the hours 6 students studied and their exam grades. So we have 6 students here, and we are using these letters to represent the students. We have students A, B, C, D, E, and students F. Now, so X represents the number of hours the students studied, and Y represents their exam grade. So in the first case, student A studied for 6 hours and scored 82%. Student B studied for 2 hours and scored 63%. Student C studied for 1 hour and scored 57%. So on and so forth. And student F studied for 3 hours and scored 75%. The task is plot the data and describe the relationship. So in this case, we have the number of students, number of hours studied, which is X on our X-axis. The horizontal line is our X-axis here. Then the exam score is on the Y-axis, the vertical line here. So based on the values, you choose a very appropriate scale. Here, the lowest number is 1, the highest number is 6. So we have the scale plotted from 1 to 6 on the X-axis. 1, 2, 3, 4, 5, and 6. And then for the Y-axis, it's a percentage score. So the highest is 100%. So, and the lowest is 57, right? So you can simply plot either from 0, or you can start from 60 or 50% and go all the way to the biggest number, or also all the way to 100, whichever works for you. But just make sure that it is evenly distributed. The scale is evenly chosen, and all the numbers will be represented or have a space on the y-axis. Now, look at the first, student A. So student A's point is here. Student A studied for 6 hours, and it's here, and scored 82%, which is this. Student A is here, 82% is somewhere here. So you run your line, this is 82%. So you don't draw a line, do use your eye to mark it. If you have a good graph, it will give you the line already. This is 82%. And then student A, you study for 6 hours. So this is his line. So the lines are meeting here. Therefore, this is the point we will make for student A, where 6 hours meets 82%. So we'll do same for the remaining of the data points. Right. So we have student A's mark here. Now, student B studied for 2 hours, which is here, and has 63%, which we are marking here. So this is for student B. This is for student A. Student C studied for 1 hour and scored 57%. So here is student C. Student D studied for 5 hours and scored 88%. Student E studied for 2 hours and scored 68%. Student F studied for 3 hours and scored 75%. So we see that all the students have their points on the scatter plots. So the scatter plot is showing a positive relationship. What does it mean? It means that we see an upward trend. If you look at how the dots are, it looks like if you pass a line through like this, you can see the points moving up. There's an upward trend of the data points. That is why we are saying that it has a positive relationship. So if you have an upward trend like this, then it is a positive relationship. And this means that as study hours increase, exam grades tend to increase. So you can see that if I'm going to use this line, which I got out of my data point, the more hours you study, the higher your grade is likely to be. This student studied for 5 hours and scored 85. 6 hours scored 83. But this student studied for just 1 hour and had the lowest grade. Right. So this is just something for us to take note of. And appreciate how a scatter plot looks like and the form it takes in presentation. Next example, a statistics teacher tracked absences and final grades for 7 students. So we have students A to G. These students attended class these number of times. Student A came to class 6 times. Student B came to class 2 times, all the way till student G, he came to class 8 times. And these are their final grades in percentages. Plot the data and describe the trend. So the same system in the previous example is used. If you look at student A, he came to class 6 times and scored 82%. So we look for 6 here, and then we trace it to 82%, and that is his point. This was student A. Student B came to class twice, yet he scored 82%. Great. So after all the data points are plotted, we can see a kind of trend in the data set. It looks like there is so let me try and draw a line through the data points. I'm seeing this kind of trend, trying to follow the data points. Great. Now this represents a negative relationship. The first one we did had a positive relationship. So this is positive relationship. Now, when the relationship is like this, we say it's a negative relationship. This means that as absences increase, final grades tend to decrease. Oh, sorry, these are the number of absences. Let me just correct myself. These are the number of absences. So the more you absent yourself from class, the likely you are to get a low grade. So this person was absent 14 times. The person who was absent 15 times had the lowest grade. And the student who was absent just 2 times had a very high grade. The student who had the highest grade was also absent just a few times, only 5 times. All right. So this is also very important. If you are absent to class more times, the tendency for you to have a lower grade is higher. All right. So we'll look at the third example. All right. 9 students recorded their weekly exercise hours and the amount of milk they consumed. These are the data sets. We have students A to I. There's a number of hours. That's the number of hours they exercise and the amount of milk they consumed. This is in Oz. Construct a scatter plot and describe the relationship. So I'm going to start by drawing my y and x axis solution. So let me draw, okay, right. Y axis. And then we have the x axis. The lowest number I see is 0, the highest number I see 10. So I'm going to mark my point so that it spans from 0 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Please take note that this is a rough sketching. Ideally, you should draw in a graph book or a well-patterned sheet. Otherwise, you can use a software to produce the graph, given the data. So we have the number of hours exercised, and then we have, so this represents the x value. Then we have y, which is the amount of milk consumed. I see that the lowest value here is 8, and then the highest is 72. So I'm going to plot from in tens. I'm going to use 10. So we have 10, 20, 30, 40, 50, 60, 70, 80, and then 90. All right. So let's look at student A. Student A studied for 3 hours, which is here, and scored 48. So 48 is somewhere here. Student B, 0, scored 8. No, sorry, I know the score. He drank 8 ounces of milk. Hello, Kwame. So student B scored 0. He exercised for he didn't exercise 0 hours, yet drank 8 ounces of milk. So we have it here. Student C, 2 hours and drank 32 ounces of milk. Student D, 5 hours and drank 64. Student E, 8 hours and drank 10 ounces of milk. Student F, 5 hours, and drank 32 hours of milk. Then we have student G, 10 hours, and took 56 hours of milk, somewhere here. Then we have 2 hours and 72 hours of milk. Then we have 1 hour and 48 hours of milk. Wow. So I see particularly in this case that I can't see a pattern. I honestly cannot see a pattern. I think that the data points are very scattered. So in this case, I would say that there is really no relationship between. So my conclusion is going to be that because I can't see either a downward sloping pattern or an upward sloping pattern. I don't really see that. It's quite scattered for me. So I would say that there is no relationship, no relationship between number of hours exercised, and amount of milk taken. There is no relationship at all, right? So this is how we go about plotting a scatter diagram or scatter plot for any kind of data set. So you see that in this case, because there is no relationship, I cannot even progress to determine what kind of relationship there exists. There has to first of all be a relationship. Then you can determine what kind of relationship it is. So this is more practice. You can try these and see if there exists a relationship. Remember, we have done an example that had a positive relationship. Example 2 had a negative relationship. Example 3 had a no relationship. So why don't you try this to see what kind of relationship exists? Is there one at all? If there is it positive or it is negative? Now, here are 4 other different kinds of data sets you can use to practice scatter plots. So in the first example, you are going to check temperature, which against electricity bills, okay? Then second example, you're going to check laptop age, number of years you've had a laptop against the battery life of the laptop. In the third example, we have the number of bags found against the days of testing. And then in the fourth example, we have the number of users online against the page load data time. So each of them, for example, number of users online, the data set is the first data set, and then the page load time is the second data set. So just put this in the table and then practice your scatter plots. First of all, identify if there exists a relationship, and then what kind, if there is, what kind of relationship is there. Thank you for being in this class. All the best in your studies, and I'll see you in the next class.